All right, we are starting Unit 8 today, and we're going to be looking at key features of quadratics. So we're going to be looking at four or five main parts of a quadratic. So the first thing we need to know is that the graph of a quadratic is called a parabola. So this curve here that you see is called a parabola. It looks like parabola, but it's parabola. So within this parabola, there are some things we need to look at. So first, we've already learned about solutions. So solutions to the graph, these might also be called an x-intercept, a root, or a zero. All of these words mean the same thing. It just wants where our parabola crosses the x-axis. So if we look, we can find one here at -2, and there's another at 4. So if you remember, we might write these answers as x equals -2, x equals 4, or I could write it -2, 0, 4, 0. Either way, that's how we would show a solution. The next word we're going to look at is another word we've already learned, and that is the y-intercept. That over here. So the y-intercept is where our graph crosses the y-axis. So if I look, here's my y-axis going up and down, and my parabola crosses right here at -8. So for my y-intercept, I would write this as 0, -8. So here's a new word that we've got, and this new word is the vertex. So the vertex is either the very top or the very bottom of a graph. So here, my vertex, I've got a bottom. So this vertex, I would say, it's at the point I go over 1, down 1, 2, 3, 4, 5, 6, 7, 8, 9. So this vertex would be at 1, -9. So again, that's the vertex. So here, our vertex, since this is at the bottom of the graph, our vertex is called a minimum. So since it's at the bottom, we have a minimum. If it were at the top would be called a maximum. Uh-oh, I knew that was going to happen. Let me see if I can write this clearer for you. So in this example, we have a minimum because it's the bottom of the graph. And then our last word that we're going to talk about is called the axis of symmetry. In our axis of symmetry, this is a line that goes through the vertex. So it's always going to be a vertical line that goes through my vertex. So here that's going to go up, it's going to go down. And how I would write this axis of symmetry is I would write it as an equation. So it's always going to be x equals, because it's a vertical line, so that's thinking back to Hoy-Vux, vertical lines are x equals. And when I look, it crosses over 1. So that equation would be x equals 1. So these are the main pieces we have of a parabola. We have the solutions, the y-intercept, the vertex, and the axis of symmetry. So we're going to look at one more graph and again pull out those 4 different pieces. So here we have a new graph. So we can start by looking for the solutions. Again, these are our x-intercepts. So if I look at my x-axis, I can find a solution here at -1, and I find one at 3. So I could write -1, 0, 3, 0, or I could write x equals -1, x equals 3. I also need my y-intercept. So my y-intercept is where it crosses the y-axis. So I can see it crosses the y-axis here at 3. So I would write this as 0, 3. I also need my vertex. And on this graph, this one's at the very top. So this vertex here is the top. So it would be called the maximum. And the point for this vertex is at 1, 4. And then lastly, we want our axis of symmetry. And that's where we go through the vertex. So I'm going to go up from the vertex. I'm going to go down from the vertex. And when I do, I cross over 1. So my axis of symmetry would be x equals 1. So on your practice, you will have a lot where you just have to tell what are the solutions, what is the vertex, what is the axis of symmetry. If you need help figuring any of these out or remembering what the difference is, please ask me or ask Ms. B. Otherwise, good luck.